work out mu from there. So, to do part B then, we're going to be using the fact that friction F equals mu times R, and if I refer you back to the original diagram, we're going to be trying to find the friction at A and the reaction at A. So we'll start by resolving vertically. And we look at all the forces that are going up equaling all the forces that are going down. Now going up, I have the reaction at A, and look here, I have the vertical component of RC. And that vertical component of RC is going to be RC cos alpha. So acting up, I have RA plus RC cos alpha. And acting vertically downwards, I have 3 mg and I have 25 mg. So that's going to equal 25 mg plus 3 mg. What I know about RC is it's 18.6 mg. I know that cos alpha is 4/5. And that's equal to 28 mg. I've got RA plus that. Right, so 4/5 of 18.6 is 14.88. So I've got RA plus 14.88 mg equals 28 mg. Therefore RA is 13.12 mg. So I have my reaction at A. What I now need is the friction at A, and I can work out mu from there. So to work out the friction at A, I'm going to be resolving horizontally, looking at all the forces that are acting horizontally in the system. So we look at this and we think, okay, acting to the right is just the frictional force, okay, and acting to the left is just the reaction at C horizontal component, which is going to be RC sine alpha. So what I have for this situation here, I have that the friction equals RC sine alpha. RC I know is 18.6 mg. I worked that out earlier, I'm just going to check that. Yep. And I know that sine alpha is 3/5 because I was given that in the question. So I work out 3/5 of 18.6, which is 11.16. So my friction at point A is 11.16 mg. I'm then going to use that friction is mu times R, maximum friction, which we knew is what we're dealing with. 11.16 mg equals mu times by 13.12 mg. Now when I divide, those mg's are going to cancel out with each other. So all I'm really doing is 11.16 divided by 13.12, which comes out as 0.8506. So to three significant figures, mu is 0.851, which is the maximum value that mu can be. The system's in equilibrium. Any more than that, then the system wouldn't be on the point of moving, any less than that, the system would already be moving because there wouldn't be enough friction to keep it in place. Finally then, part C is asking us about modelling assumption. State how you have used the information that the peg is smooth. Well, the peg is smooth, which means that there is no friction at C. So the peg is smooth, therefore there is no friction at C. So there we go. Just like example 1, we did a moment, we resolved vertically, we resolved horizontally, and a combination of those three things was enough to tell us everything we needed to know to find what the question was asking us to find out. Job done.